Welcome to Fall Protection Training for the Construction Industry. This training covers the hazards of falls and the importance of protection, the roles and responsibilities of a competent person, the hierarchy of fall protection, and responding to falls. Most job sites have unprotected sides and edges, wall openings, or floor holes. If these sides and openings are not protected, injuries from falls or falling objects may occur. Falls on work sites are often caused by unstable working surfaces, poorly positioned ladders, and the misuse of fall protection. Falls cause more deaths in construction than any other hazard, accounting for about 1/3 of the total number of fatalities. Fall protection consistently remains at the top of OSHA's list of most frequently cited standards. In 2018, OSHA dealt 7,270 citations related to the fall protection standard. A competent person must be designated to monitor the safety of employees. This person must be able to recognize fall hazards, train employees who might be exposed to them, and warn employees when it appears they are unaware of a fall hazard or acting in an unsafe manner. The competent person must be qualified in the following areas: correct procedures for erecting, maintaining, disassembling, and inspecting fall protection systems, the proper use and operation of protective systems, and correct procedures for equipment and material handling, as well as storage and erection of overhead protection. The Fall Protection Standard requires fall protection for employees working more than 6 feet above the ground. This rule also applies at heights less than 6 feet when employees are working near dangerous equipment, like over machinery with open drive belts. Employees on a walking or working surface with an unprotected side or edge that is 6 feet or more above a lower level must be protected from falling using guardrail systems, safety net systems, or personal fall arrest systems. Employees constructing a leading edge 6 feet or more above lower levels must be protected from falling using guardrail systems, safety net systems, or personal fall arrest systems. Scaffolding more than 10 feet above a lower level must be protected by guardrails or personal fall arrest systems. This threshold differs from the standard requirement for the use of fall protection at 6 feet for most construction activities. Different thresholds are required because scaffolds are temporary structures erected to aid workers who are constructing or demolishing other structures, and scaffolds are less amenable to the use of fall protection at the time the first level is erected. Employees on walking or working surfaces must be protected from falling or stepping through holes, including skylights, more than 6 feet above a lower level, using personal fall arrest systems, covers, or guardrail systems erected around the hole. Employees at the edge of an excavation 6 feet or more in depth must be protected from falling using guardrail systems, fences, or barricades when the excavations are not readily seen because of plant growth or other visual barriers. Employees in a hoist area must be protected from falling 6 feet or more to lower levels using guardrail systems or personal fall arrest systems. If guardrail systems are removed to facilitate hoisting operations, employees must be protected from fall hazards using a personal fall arrest system. Employees less than 6 feet above dangerous equipment must be protected from falling into or onto the equipment using guardrail systems or equipment guards. Employees 6 feet or more above dangerous equipment must be protected from fall hazards using guardrail systems, personal fall arrest systems, or safety net systems. Workers must be protected from falling objects by canopies that won't collapse or tear, toe boards 3.5 inches high that can withstand 50 pounds, panels or screens when material is piled higher than a tow board, and barricades or fences that keep workers and the public away from areas with possible falling debris. There are a variety of methods used to protect employees from fall hazards. The diagram details these methods, which decrease in effectiveness as you move down. Elimination is the most effective form of fall protection because it completely eliminates the hazard. Using this method, fall hazards are evaluated to determine if a change in the procedure, practice, location, or equipment will remove the risk to workers altogether. An example of elimination can include covering up a hole in the floor to prevent workers from falling through it. Passive fall protection like barriers and guardrails can be useful in preventing falls and subsequent injuries. Guardrails are generally more effective than personal protective equipment as they require minimal training to use properly. If installed with a tow board, guardrail systems can also protect workers on lower levels from falling objects. Top rails must be 42 inches plus or minus 3 inches above the walking or working level. Mid-rails and similar intermediate structures must be installed between the top edge of the guardrail and the working surface when there are no walls at least 21 inches high. Tow boards must be able to withstand a force of at least 50 pounds. Guardrail systems must be able to withstand a force of at least 200 pounds when force is applied within 2 inches of the top edge in any direction and point along the top edge. The surface must be smooth as to not injure workers or snag on clothing or materials. If wire rope is used for top rails, it must be flagged at no more than 6-foot intervals with high visibility material. Manila, plastic, or synthetic rope used for top rails or mid-rails must be inspected to ensure its strength and stability. If wood guardrails are used, the posts must be at least 2 inches by 4 inches, and the lumber should not be spaced more than 8 feet apart. Fall restraint systems can help prevent falls from happening. Fall restraint systems use PPE to restrict the worker's range of movement so they cannot physically travel to a fall hazard. They are preferred over fall arrest systems, which protect workers who are already in the process of falling. Positioning devices are fall restraint systems that hold workers in place on an elevated vertical surface, allowing them to keep both hands free to work while leaning. Body belts may be used in limited instances, for example, only as part of a positioning device system. In general, harnesses are preferred to body belts. Fall arrest systems are used where falls may occur, but workers are stopped in descent, with the goal to stop the fall before the worker hits the ground. Additional training is required for the safe use of fall arrest systems. Personal fall arrest systems should be set up so workers can neither free fall more than 6 feet or make contact with a lower level. Bring a worker to a complete stop and limit the maximum deceleration distance a worker travels to 3.5 feet. And be inspected prior to each use for wear, damage, and other deterioration. Personal fall protection systems have 3 components. Anchorages are secure points of attachment for lifelines, lanyards, or deceleration devices. They must be designed, installed, and used under the supervision of a qualified person. Anchorages must be capable of supporting at least 5,000 pounds per worker. Body harnesses are straps that are secured to workers to distribute the fall arrest forces and able to attach to other components of a fall protection system. When using a body harness, the maximum arresting force on a worker must be limited to 1,800 pounds. Personal fall protection systems may not consist of a body belt. Body harnesses must be inspected daily. Connecting devices are used to connect parts of personal fall protection systems and positioning device systems together. A connector may be an independent component of the system, such as a carabiner, or it may be an integral component of part of the system, such as a snap hook sewn to a lifeline or self-retracting lanyard. Snap hooks are used to hold the component parts of personal fall arrest systems together. Snap hooks are extremely durable and designed to be self-locking and self-closing. No matter how strong a snap hook is, you must use them in a safe manner, following the manufacturer's instructions closely. A deceleration device is a mechanism, such as a rope grab or self-retracting lifeline and lanyard, used to dissipate a substantial amount of energy during a fall arrest. Self-retracting lifelines and lanyards automatically limit freefall distance to 2 feet or less, and must be capable of sustaining a minimum tensile load of 3,000 pounds applied to the device with the lifeline or lanyard in the fully extended position. Warning line systems are barriers erected on a roof to warn workers that they are approaching an unprotected roof side or edge, and are only used in specific roofing situations. Safety net systems are passive protection designed to catch workers or debris in the event of a fall, and must be as close as possible to the working surface, inspected weekly, and tested using drop tests. A personal fall arrest system can save your life if you fall, but your harness won't hold you comfortably while you're suspended. If you can't relieve the pressure it exerts on your legs, which constricts blood flowing back to your heart, you could lose consciousness. The foot wrap will relieve the pressure and allow you to climb up or down for short distances. First, grab the lifeline hanging below and wrap it around your right foot, starting from the inside. Then stretch the lifeline out horizontally and step into it with your left foot. Raise the trailing end of the lifeline and bring both parts together. You have now created a loop that will allow you to stand. Continue to hold onto the lifeline with both hands and stand up in the loops. This will relieve pressure on your upper legs. When you get tired, you can shift back to a sitting position. While waiting for help, alternate between sitting in the harness and standing. You can also distribute weight between your feet and the harness. To climb up or down short distances, slide the rope grab up or down, sit back down, then grab another section of rope and repeat the process. Anyone who is suspended from a lifeline and can't perform a self-rescue will need help from trained rescuers. Consider, for example, the worker who has a heart attack and falls, or a suspended worker who is injured as a result of the fall. Aided rescues involve trained rescuers and appropriate equipment. Keep in mind the following in deciding what equipment is appropriate. Can you use extension ladders, forklifts, or elevating platforms to perform aided rescues? Or do you need technical rescue equipment? Will the equipment be available and ready to use when you need it? Can rescuers always reach a suspended worker with the equipment? Do rescuers know how to use the equipment? If possible, use on-site equipment for aided rescues. Only if this equipment isn't available or isn't appropriate should you consider using technical rescue equipment. Technical equipment appropriate for aided rescues includes pulley systems, brake tube systems, and winch systems. Let's review what you've learned. Falls cause more deaths in construction than any other hazard. A competent person must be designated to monitor the safety of employees. A variety of fall protection protocols are used to safeguard workers, including guardrails, personal fall protection, such as fall arrest and fall restraint systems, and safety net systems. The components of personal fall protection include anchors, a body harness, and connectors. In the event of a fall, use a foot wrap to relieve pressure from the body harness. If pressure cannot be relieved because the worker is unconscious or otherwise cannot perform a foot wrap, aided rescue is required.